वेलकम टू वीलर्न में आपका स्वागत है. We are discussing marketing research session 11, analysis of associations. Topics covered are cross tabulation, chi-square test for analysis of association, strength of association between two nominal variables, correlation coefficient, simple linear regression, and analysis of difference. In this particular unit, we would be concerned mainly with the cross tabulation of data and their interpretations, and the kind of analysis of association by using chi-square test and correlation coefficients. Now, the cause and effect relationship between two variables, they will be examined by simple linear regression model. We would be testing of the statistical significance on sample drawn from bivariate populations. Now, cross tabulations when we talk. Now, a matrix which is displayed in the next slide, it displays the categories of two nominal scaled variables. They contain the frequency count of the numbers of subjects in each bivariate categories, and they are called cross tabulation table or contingency table. Now, while preparing the cross table to examine this simultaneous relationship, a table like this would be considered. Here in this table, there are survey which is done on preference for new packaging design. So they contain respondent number. On the next column they have their preference. Then a preference code is assigned in the column 3. In column 4 their sex is mentioned. Then their marital status in column number 5. Column number 6 contains their age in years. Number 7 is a code of their education. Number 8 column they have their actual income. Then column 9 contains their income code, and lastly column 10 contains their region code. Now there are respondents, like there were 10 respondents which are shown here in this tabulation. So likewise their preference is given in terms of in the column 2, and whether they're interested and not interested, these are the codes which are assigned in their preference code column number 3. When we talk about preference versus marital status, so as it would be indicated in the table, this table, the respondents are basically divided into two categories, married and singles. Now there is this variable, when cross tabulated against the preference variables, they show the following result. When we talk about married, those who are not interested, they accounted for 18, which is 40%, and married people who are interested, they accounted for 12, that is 60%. So the total came out to be 30 for the entire 100%. Now, for single who are not interested, they accounted for 50%, that is 15 in number, and for interested, they were 15 in number, which also accounted for 50%. So this is 30 in total and accounted for 100%. Now the sample, it comprises of equal number of married and single respondent. So there are 40% of the married people and 50% of the single respondent who were showing their interest in favor of the new design. Likewise, when we discuss about chi-square test for analysis of association. Now the association between the two cross-tabulated variables, they can be done by computing the percentages in the direction of casual variables. But yes, the same analysis, it can be carried out by using chi-square test of independence between the two variables, and they are categorized into two or more groups. Now they could be examined by null hypothesis. So when we talk about null hypothesis, the two variables, they are not related to each other. Another is alternate hypothesis, where there is a dependence of the two variables. Now to test these hypotheses, chi-square test of independence can be applied. Now the frequency which are obtained, they are observed from the surveyed data, whereas the corresponding expected frequencies, they are computed under the assumption that the null hypothesis is true. So corresponding to a contingency table, the expected frequency Ij is called for. So Eij is the expected frequency which is corresponding to the cell in the ith row and jth column. Ri is the total of observed frequency of corresponding to the ith row. Cg is the total of observed frequencies corresponding to jth column. G is the grand total of frequency. Now the formula which is used is Eij, which is equal to Rj into Cj divided by G. Now the statistic, the chi-square statistic, is computed by using another formula, which is x square r minus 1 into e minus 1, where now in this formula, Oij stands for the observed frequency of the cell in the ith row and the jth column, and Eij refers to the expected frequency of the cell in the ith row and the jth column. Now here r minus 1 and c minus 1, they indicate the degree of freedom, where r stands for the number of row and c stands for the number of column. Now for any given level of significance, the computed chi-square value, it is compared with the tabulated chi-square value. In case the computed chi-square is greater than the tabulated chi-square, we reject the null hypothesis to conclude that the variables, they are dependent. Then we talk about the strengths of association between the two nominal variables. There is a relationship between a variable, and it is very interesting to note and examine the strength of association between these two variables. Now there are three methods to determine the degree of association. The first is the contingency coefficient. When we talk about contingency coefficient, here the null hypothesis of independence between two nominal variables, it is rejected. And what happens, they also desire to measure the degree of association between them. One such measure, it is called as contingency coefficient, and it is denoted by C, which is equal to underscore x square divided by n plus x square, where x square is basically computed by the method which is discussed in the previous section, and n is the total size of the sample. Now we understand that the computed value of x square, which is corresponding to the hypothesis number 1, is 8.91. So the corresponding contingency coefficient, that is C in this case, would be 0.36. That is, C is equal to underscore of 8.91 divided by 60 plus 8.91 underscore. So the value comes out to be 0.36. When we discuss phi correlation coefficient, this is basically used to measure the strength of association for two nominal variables in a contingency table where the order is 2 by 2 and is basically termed as phi coefficient. Now this phi coefficient, like the correlation coefficient, it can assume any value between -1 and 1. Now phi coefficient, the square of phi coefficient, when we discuss, it measures the proportion of one variable that is explained by the another variable. Now in this 2 by 2 cross tabulation table, which are corresponding to hypothesis number 1, here we wish to examine the strength of association between preference for new design and education level. For the sake of convenience, the data is reproduced like this. And the phi coefficient, it may be calculated using the formula phi is equal to AD minus BC divided by underscore A plus B multiplied by C plus D multiplied by A plus C multiplied by B plus D. So the resultant value is 0.385. Now according to the above description, there is a very weak association between the preference and the education. The value phi square comes out to be 0.15, which indicates that 15% of the variations in preference is explained by the education level. Then comes Godman's and Kruskal lambda. So here the two measures, namely the contingency and the phi coefficient, they are symmetrical measures of association in the sense that they do not predict the others. But there can be instances where a marketing researcher, he desires to determine the direction of prediction. So to meet such a requirement, Goodman and Kruskal's lambda asymmetric coefficient, they may be used. This method is used to measure the extent to which we may reduce the error in predicting categories of one variable from the knowledge of the categories of the other variables. When we say correlation coefficient, it is basically the degree of association between two variables, and this is also computed by using correlation coefficient. Now a measure of linear correlation coefficient between two variables x and y is measured by correlation coefficient, and the formula thus becomes R equals to this formula, where x bar stands for the sample mean for the variable x, y bar stands for sample mean of the variable y, and n stands for the number of observations in the sample. Now this also assumes any value between -1 and 1, and therefore it is independent of the units of measurement. Now the correlation coefficient, it could be computed for intervals and ratio scale data as well. Now to test the significance of population correlation coefficient, we may use t-test described like when null hypothesis there is a relationship between, and there is no relationship between preference and income where p is equals to 0, and alternate hypothesis, yes, there is a relationship between preference and income. Now to test statistical used to test the hypothesis, it is given by this formula where R stands for sample correlation coefficient and N stands for the sample size. Now, simple linear regressions, when we talk, there are limitations of correlation analysis, and because it only measures the degree of association between two variables and they do not deal with the cause and effect relationship between the variables. Regression analysis, however, overcomes these problems by using a very casual relationship between the variables. Now, assuming y is a function of x, we are treating x as a casual variable and y as a dependent variable. So this means it is only the variable x which influences the variable y and not the other way around. Now, assuming a linear relationship between the dependent and the independent variable, the relationship between y and x can be written like this, where b0 is the intercept term, b dash is the slope term, and u refers to the random error. Now, the estimation of b0 and b1 is carried out by using ordinary least square method of estimation. The ordinary least square method, it aims at minimizing the error sum of squares to obtain the estimated value of intercept term and the slope term. Now, analysis of difference, when we talk about null hypothesis, there is no difference between the monthly income of those who are interested in the new design and those who are not interested in the new design. And when we talk about alternate hypothesis, the monthly income of the respondent preferring the new design is not equal to those not preferring the new design. The second is the case where the proportion of females preferring the new design is equal to the proportion of males who are preferring the new design. And another alternate hypothesis is the proportion of females preferring the new design is not equal to the proportion of males preferring the new designs. Two exercises that needs to be done. What are the ways in which percentages may be computed in cross tabulation table? Which way is the best? In a contingency table, what type of hypothesis is tested using chi-square test? What precautions may be taken while applying the test? Thank you and have a nice day. Keep learning and relearning.